All right, we're going to look at the first lesson of this type on problem solving, where we will use all the skills that we've been working on in previous lessons. All right, when you have an application problem, sometimes called a word problem, there are some basic steps that you need to try to solve, to use in order to get a good solution. Number one, familiarize yourself with the problem situation. If it's presented in words, and it could be in a chart, this means to read and reread it carefully until you understand what you're being asked to find. It might help you to make a drawing, might help you to make a list of facts, assign a letter or a variable to the unknown quantity, organize things in a table or chart, find further information, like look up a formula, and maybe guess or estimate the answer. Okay, you will not have to do all of these, but as algebra becomes more complicated, more of these become involved in trying to solve a word or application problem. All right, then we're going to translate the problem into an equation using the variable, I'm going to use x probably each time. Then we're going to solve the problem. The problem will be solvable using the two skills that we learned in the previous lesson. Check to see whether your possible solution actually fits the problem situation and is really the solution to the problem. In other words, is it logical? For instance, if you were asked how much time and you got a negative number, then that would be an issue because time's not supposed to be negative. Okay, then state the answer clearly using a complete sentence and appropriate units. In my math lab, you won't be typing the sentence, but the sentence will be there. And so please notice that. When it comes time to do some translation or at least understand better what's going on, you might write down this list and keep it in your notes. Addition, it may be indicated very clearly by the words add or added to, but it might be the word sum, total, plus, more than, increased by. Subtraction, subtract, subtracted from, difference, minus, less than, decreased by, take away, how much more. Multiplication, multiply, multiplied by, product, times, of. Now, of typically only implies multiplication if you're dealing with fractions, like half of 24. That would mean 1/2 times, but we're not working on fractions yet. Repeated addition, or a rectangular array. If you have so many rows and so many items in each row, you might need to multiply to find your quantity. Okay, finally division, divide, divided by, quotient, repeated subtraction, missing factor, or finding equal quantities. You want to put candy into bags for 5 children. How would you divide it up so that they get equal quantities? So these different phrases fit with certain operations. And remember, when we see the unknown, what we're looking for, we're going to let x equal the unknown. Okay? Let's look at problem number 1. The first thing we're supposed to do is get familiar with it. All right, here we go. An 8-ounce serving of an energy drink contains 81 milligrams of caffeine. An 8-ounce serving of coffee contains 22 more milligrams of caffeine than the energy drink. How many milligrams of caffeine does the 8-ounce serving of coffee contain? All right, so the question, how many milligrams of caffeine does the 8-ounce serving of coffee contain? So I'm going to make myself an initial note. X represents the caffeine in the coffee. The problem talks about 8-ounce servings, 8-ounce servings. So that's just letting me know that for the same amount of drink. All right, now let's go back. And it says the 8-ounce energy drink contains 81 milligrams of caffeine. The coffee, oh, that's what I'm looking for. The coffee contains, has, is equal to 22 more milligrams of caffeine than the energy drink. So the the coffee is, oops, I'm so sorry, 22 more than the energy drink, and the energy drink was 81. Well, go away. Oh my goodness. I don't know why I'm not getting to have a pen. There we go. All right, so the coffee has 22 more than the energy drink. So if I wrote that, coffee has 22 more than energy drink. And then I fill in coffee has. Now many times the verb has, is, was, will be. That's your equal sign. 22 more than the energy drink. So it wants to know how many are in this. So let's see. X is 22 plus 81. 22 plus 81. 113. Oh, I'm sorry. How about if I add correctly? 2 plus 8 is 10, not 11. So it is 103. So I could say, if I were writing a sentence, they have my sentence. The 8-ounce serving of coffee contains 103 milligrams of caffeine. I know that you probably could have figured this out without an equation, but we're trying to do some preparation for future classes when you will have to have an equation to be able to solve an application problem. All right, let's look at number 2. It says there are 506 members in a band, and they are marching with 23 members in each row. How many rows are there? Okay, that means that we have lots and lots of members. We have 506 of them. And as a band director, you're saying, I want 23 in this row, and 23 in this row, and 23 in this row. So, how many rows will there be? Can you see that you are let me go back. X is the number of rows. Now, if I went back up to this, finding equal quantities, okay, you are taking this mass of people and you're dividing it into groups of 23, and you want to know how many there will be. So you are taking 506 and you are dividing it by 23 to find out the number of rows. 1 row, 2 rows, 3 rows. So this was a case where, kind of drawing a little picture or thinking about it in my head, I'm literally taking 506 and taking off 23, 23, 23. So now if I do that division, 23 does not go into 5, so nothing in the first position, but it does go into 50. Well, how many times? How about 2? 2 times 23 is 46. Subtract, and I can't subtract, so I have to borrow. 6 from 10 is 4. Nothing there. Bring down a 6. Does 23 go into 46? Yes, we already saw that. It went in 2 times. 2 times 23 is 46. And remainder 0. That means that 22 is X. My statement up here says the number of rows is 22. So if you have 22 of these 23s, you would have 506. Let's look at our third one. An office building is 1,607 feet high, and a hotel is 849 feet high. Find the difference in the height between the two buildings. So X is the difference in height. And you notice that I abbreviate sometimes when I'm saying what my X stands for. Difference means to do what? Means subtract. So X is 1607 minus 849. This will give me the difference. 1607, 849. Can't subtract there, can't borrow from a 0, got to go all the way down here, drop off a 1, borrow from it. Now I have 9 from 17 is 8, 4 from 9 is 5, 8 from 15 is 7. So the difference is 758. The difference in the height between the two buildings is 758. All right, let's look at number 4. A computer screen consists of a small rectangular dots called pixels. Find the number of pixels on a screen that has 500 rows with 800 pixels each. Let's go back up to our words. A rectangular array, 500 rows of 800 pixels each. So, X is the number of pixels. So X is, there are 500 rows, there are 800 pixels on each row. So I have 500 times 800. 0 times 0, 0 times 0, 0 times 5. Scoot over, 0 times 0, 0 times 0, 0 times 5. Put in my 2 placeholder zeros. 8 times 0 is 0. Hello. 8 times 0 is 0. 8 times 0 is 0. 8 times 5 is 40. Excuse me. I have 0, 0, 0, 0, 0, 4. Let's put the comma in there. And I have X is 400,000, naming that period. So in here you will type there are 400,000 pixels. All right, let's look at number 5. Okay, we've got a chart or a graph. The graph shows the average monthly rent for a one-bedroom apartment in several cities in June of 2008. Okay, let's look. City A, City B, City C, D, and E. It has the average rate. This is rent per month, so this must be money. How much higher is the average monthly rent in city E than city C? E and C. How much higher? What's the difference? So X is the difference. How much higher? Okay, I may have run off the screen there. All right, so I'm going to take the bigger one, which is 779, and take the difference between 757. That should give me the difference. So I'll come over here, 779, 757. That's 2. That's 2. It looks like 22 is the difference, and that's money. It is $22 higher in E than it is in C. Oops, I mean to make it go all the way away. There we go. All right, this is number 6. The average monthly rent for a one-bedroom apartment in a city is $735. Phil, Scott, and Julio plan to rent a one-bedroom apartment immediately after graduation, sharing the rent equally. I hope it's a big bedroom if all 3 of them are going to share. What's the average monthly rent each of them can expect to pay? All right, let's go back up here to our words and see what applies. We're going to find equal quantities again. All right, so in other words, we're going to divide the rent 3 ways. So X is each person's rent. And I have 735, and I'm going to divide it 3 ways, and that's going to give me each person. Okay, and I guess I need to do that. 735 divided by 3. Now 3 does go into 7. It goes 2 times, so I get a number above the 7. 2 times 3 is 6. Get a 1 and bring down the 3. 3 goes into 13. Well, it goes 4 times. 4 times 3 is 12. 1 and bring down the 5. 3 goes into 15 5 times. 5 times 3 is 15. So I have a remainder of 0. Each of these guys needs to plan on spending $245. Now, the way I set these problems up, because of the kind of problems they were, you didn't actually solve them as equations where you add to the same side or subtract from the same side or divide. Instead, I made sure I was looking directly for the unknown, and I was trying real hard to use these key phrases or concepts. So I think you can do just fine doing this with your problems. I strongly encourage you to make a statement for yourself. What are you looking for? And take the time to actually write it down. That will be very helpful in future problems.